A sequence is said to be geometric if the ratio between two consecutive terms is constant. This ratio is called the common ratio and is denoted by R. So R can be found as dividing the next term by the preceding term, or in general, R is written as an divided by an minus 1. From which, if I do cross multiply, then an is equal an minus 1 multiplied by the common ratio R. And this is the recursive formula. Let's have an example about this. For the following sequence, find the common ratio. So R is given by -2 divided by 8, simplify it, -1 out of 4. The same as if we divide 1 over 2 by -2, which is -1 out of 4. To find the nth term, or the general term, or the last term, we use the following formula. An is equal a1 r to the power n minus 1. And this is the explicit formula. As an application, given the following numbers, 189, 151.2, 120.96, and we need to find the 27th term. To do so, we need to find the common ratio R by dividing 151.2 by 189, which is 0.8. So A27 is equal A1 multiplied by the common ratio R to the power 27 minus 1. And the first term is 189, and the common ratio is 0.8 to the power 26, which is approximately 0.57. In the next example, given the third term, 32, and the common ratio is -4, we need to find the 12th term. Applying the formula of the nth term, a1 multiplied by r to the power n minus 1. But unfortunately, we don't have the first term. So this formula should be adjusted as A12 is equal to A3 multiplied by the common ratio R to the power n is 12 minus 3. So this number should be the same as this number. So A12 is equal to, the third term is 32 multiplied by negative 4 to the power of 9. And the answer is given as the next idea is about geometric means. The question: find two geometric means between 48 and negative 7.5, which means that the first term is 48, the next is missing, the next is missing, and the last term is negative 7.5. From which we can deduce that n is 4. We have 4 terms. The first term is 480, and the fourth term is negative 7.5. I need to find the common ratio. From the formula, an is equal a1 multiplied by r to the power negative n minus 1. So a4 is equal a1 times r to the power 4 minus 1. The fourth term is negative 7.5, and the first term is 480 multiplied by r is missing to the power of 3. To isolate r, we divide by 480 both sides. Then r to the power 3 is equal negative 1 over 64. To get rid of the exponent 3, we do cubic root both sides. Then r is equal to negative 1 over 4. Which means that the second term is equal 480 multiplied by negative 1 out of 4, which is negative 120. And a3 is equal the term before, which is negative 120, multiplied by negative 1 out of 4, which is 30. The last part is about geometric series, the sum of the terms of a geometric sequence, and the formula is given by Sn is equals to the first term a1 into 1 minus r to the power n divided by 1 minus r, or it has another form. Sn is equal to a1 minus an multiplied by r divided by 1 minus r. In fact, this formula can be used if n is given, and the other one if n is not given. The first example about this: let's have the following series 14, 24.5, and I need to find the sixth sum, or the sum of the first 6 terms. From here, n is given, which is 6, so I can use the first formula. What I need is to make sure this is a geometric sequence. So 14 divided by 8, which is 1.75. 24.5 divided by 14, which is 1.75. So this is a geometric series. The sum is given as mentioned above, a1 into 1 minus r to the power n divided by 1 minus r. So S6 is equal, the first term is 8, 1 minus, the ratio is 1.75 to the power n, which is 6, divided by 1 minus 1.75. Direct application. After calculations, the answer is 295.71. The second example, given the first term 3, the nth term or the last term is 768. The common ratio is -2. We need to find the sum where n is not given. So I'm going to use the second formula, Sn is equal to a1 minus an r divided by 1 minus r. Replace 3 minus 768 multiplied by r, which is -2, divided by 1 minus -2. Just do calculations and the answer is 513. The next example, find the sigma of 3 multiplied by 5 to the power n -1 and -1 from n equal to n equal 7. If you know from the beginning this is a geometric series, then it's fine. If not, you're gonna replace the first term n equal to 3, 5, 2 minus 1, which is 15. The second term for n equal 3, replace 3 minus 1, which is 75. If you want to continue until you reach n equals 7, it's fine. Three, 5, 7 minus 1, and you can find the last term. But I say, if you have many terms, nonsense to find all of them, then you can add them. So what we do is to find the common ratio, which is 75 divided by 15, which is 5. And then I can apply the formula Sn equal A1 1 minus R to the power of n divided by 1 minus R. Because the first term I have it, which is 15, 1 minus, the common ratio is 5, to the power n. How can I find n? Look at the first term, lower boundary and the upper boundary. We do 7 minus 2 plus 1, which is 6. This is how you find n. So to the power of 6 divided by 1 minus 5. After calculations, the answer is 58,590. Now the problem is, what if the sequence goes for infinity? That's what we call it, infinite geometric series. That is when n approaches infinity. There is no limit for the geometric series. Then according to the formula, A1 1 minus R to the power n divided by 1 minus R. In fact, it depends on the value of R. If the absolute of R is greater than 1, then we will not have the sum. If R absolute less than 1, then we have a sum. And since absolute R less than 1, then R to the power n as n approaches infinity is equal to 0. And the formula becomes A1 divided by 1 minus R, because this term becomes 0, and A1 multiplied by 1 is A1 divided by 1 minus R. So we're going to apply this formula in case R, the absolute R, is less than 1. Let's have an example. Find the sum of the following geometric series. So by default, the common ratio is 3 divided by 9, which is 1 over 3, or 1 divided by 3, which is the same. The R is 1 out of 3, which means it's less than 1. So the sum exists, and we're gonna find it as A1 divided by 1 minus R. The first term is 9 divided by 1 minus 1 divided by 3. And the answer is 13.5. The second example, (0.25) plus negative 1.25 plus 6.25, etc. So let's have the common ratio. Negative 1.25 divided by 0.25, which is negative 5, which means that the absolute value of the common ratio is greater than 1, which means there is no sum.